welcome to the ASTRO. So in this part 3 tutorial on Specutils, we are going to estimate redshift of a galaxy from a spectra. So redshift tells us that how fast your galaxy is coming towards you, or how fast it is going away from you. So that can be defined in terms of your spectral wavelength, which is delta lambda by lambda rest, and where delta lambda is lambda observed minus lambda rest, or in the live frame divided by lambda rest, which is also equal to v by c. Okay, so let's uh, find z from this spectra. So for example, we have, this is our h alpha line. Okay, so we know that h alpha line has some wavelength in the live frame, and we also know that uh, and we'll also know that like where the peak of this line lies in your in your uh, moving frame. So if you take a difference and divide by lambda rest, then we'll get a z simply. So let's do it. Okay, so first what we'll do, uh, so first I will plot, so I will plot continuum fitted spectra. Okay, continuum subtracted spectra. So you can also watch my other videos, part 1 and part 2, if you are new visitor and you are not feeling comfortable with these things. Okay, so I will just copy paste here from our earlier videos, earlier lectures. So here I will plot and just simply we paste the code. Okay, so here I will get my continuum of subtracted spectra. Okay, now what I will do, I will try to find, and also this spectra is in moving frame. Okay, in sets in moving frame. Okay, this spectra in the moving frame. So what I will do, I will try to plot, say that a spectra for a small region, and I will try to find the peak value of this line. Okay, in the moving frame, and I already know the h alpha value in the rest frame is 656564 angstrom. So we can take difference and divide, and then we simply get the z. Now this much we have done. So now I will try to here. Okay, so plot a small portion of this spectra. Okay, so for time being, I will try to modify my code, and I will try to do slicing using a numpy. So here I can define my say a spec underscore portion equal to, I will try to or maybe you can flux, you can say flux, you can say y cut, and you can say x cut. Okay, so x is your wavelength, x cut and y cut. So you can put here and your wavelength cut. So I will try to cut the wavelength. So I will try to cut wavelength in this region, say from 2300 to 2450, and same for the continuum fitted, and also for the wavelength. Okay, so now if you plot here x cut and y cut, so here you can see that now you have a portion of this spectra. Okay, so you got here portion of this spectra, small portion. Okay, so now you want to find the peak of this line, and then you can get the at what wavelength the peak has the highest value. Okay, so now let's do it. Okay, so for that I will find peaks. Okay, so I will find peaks. So for that I will import SciPy library. So you can so I will find peaks. So I will import library. So import SciPy library. So from SciPy dot signal import find peaks. Okay, now what I will do, I will find the peaks in the peak positions in the your spectra. So I will say it's I peaks, comma, and then underscore, and then find underscore peaks, and I will pass my flux. Okay, so you can pass your y cut. Okay, y cut. Now, so now run it. So what you got here, I picks. So this is like position, this is like index, and this is like position at which like your this spectra has peaks. Okay, now find the index from the maximum peak. Okay, so find index of maximum peak. Okay, so this will like give you the index of the peaks. So this is like peaks. Okay, now find index. So you can say I max underscore peak equal to I peaks, and then you will try to find its location. So for that, np dot argument max. So this will like the location of your maximum value. Okay, so then I will pass your y, pass your y cut, and then give your I peaks. So I peaks from that array. Now run it. So now they see what it is giving I max. So I max peak So you can see that at 88 positions here, the spectra has the highest peak. Okay, so it will it will give it will give index of highest peak. Now this is what we have done. Now I will try to find that if for what value of the wavelength this peaks. So we know that at 88 positions the peaks. So what is value corresponding to that 88? So here find a wavelength corresponding to your corresponding to 88. So for that, type here x, or maybe you can say, yeah, or you can say x max equal to, you can pass your x cut, right, and then you pass your I max peak. Now run it. So see what your x max is. So x max is your this much wavelength. Okay, so this will give wavelength in moving frame. Okay, in the moving frame, right? So this is the wavelength, and you can check it. It is coming here. It is coming around 6640. Now, so you can print here simply. Print your observed wavelength. Observed wavelength is such that, and pass your x max. Okay, so there's a comma. Okay, so this is this much is angstrom is observed wavelength. Now you want to also, we know that h alpha line has 6564 angstrom in rest frame, right? So you can print here. You can clear of h alpha line, print like this. And then you can also print the same thing, that the rest wavelength. So rest wavelength line is say 6564, right? 6564. You can type here angstrom if you want. R is this much angstrom. We can just give the unit here is 6564. Okay, now we have to apply the above formula, right? So you can now find z redshift equal to your lambda absorbed. So your lambda absorbed is this much, right? Then your rest wavelength, your rest wavelength is this much, and then you have to divide it by lambda rest, right? So 6564. So z equal to, now print redshift of this galaxy using H alpha line is such that z, there's a comma. Okay, so we have estimated that the redshift of this galaxy is 0.01165. Okay, now we can compare this from our given value in the catalog. Okay, so go to our part 1 tutorial, and we'll see that we have obtained that from the data, that from the catalog, that the redshift of the galaxy was 0.0114. Okay, and we have obtained this value using H alpha. So we'll go to part 3, and we have obtained this value from our, this is from our catalog. Okay, so you can compare that up to 3 digit upper decimal we are matching accurately. This is a good tutorial to learn that how to find redshift of a galaxy using peaks present in your H alpha line, or any, you can use any line like O3 lines, N2 lines, like use maximum peaked value H alpha line. This is like your H alpha line, right? So here's a code. So I've tried to find so basically what I have done, I have tried to plotted the spectra in like very small portion. Then I've tried to find the peaks, that how many peaks it contains. Then I've tried to find the position of the maximum, I mean index of the maximum peak, and from there I've tried to find that at what wavelength the maximum peak occurs, and then I've obtained the rest wavelength of H alpha line, and I've obtained observed from this spectra. Then I've applied the formula, and I've got redshift of this much, which is matching from our catalog up to 3 decimal places. So I hope this tutorial has helped you to get insight about how to extract galaxy redshift from SciPy. So thank you.